Hello. Now we're going to learn about sample means. Sample means are pretty similar to what we did last chapter with sample proportions, but now we're going to um, just use means. Now, the proportions are usually used with categorical variables, where sample means are often used with quantitative variables. So we use proportions when we say like 34% of the population is on free and reduced lunch. But when we want to find the heights or something quantitative, we'll usually look at the means. So for instance, here's a couple things. Here's stocks. Now, when you buy individual stocks, there's a lot of variability. There's stocks can earn a lot of money. They can also lose a lot of money. But if you have a portfolio like a mutual fund takes a bunch of stocks and combines them together. So when you combine together stocks, uh, you don't really have the swings as good or as bad as you do with individual stocks. Uh, that's good and it's bad. You can't make as much money, but you also can't lose as much money. These are just safer bets. So means of random variables are less variable than individual observations. Also, means of random samples are more normal than individual. You can see that both these look fairly normally distributed, but we'll learn more about the normality um, as we move along through this. Now, the means and standard deviations are fairly similar. The mean of our x-bar distribution, we'll call this an x-bar distribution instead of p hat, is going to be the true mean. Now the standard deviation is the standard deviation for the entire population divided by the square root of n. Now we'll put this into practice pretty soon. Now the sample mean x bar is an unbiased estimator of the population proportion of mu. That means if I sample all the possible x bars in a situation, the mean of that distribution will be exactly mu. As the n increases, so as we are taking the mean of more and more numbers, the standard deviation will decrease. And again, we can only use the standard deviation when the population is at least 10 times as big as our sample, and that's for independence.